majority of them go in the middle, and then only some go out here. And it says the theory of probability is nothing more than good sense confirmed by calculation. So yeah.
In 7-6, we're learning about binomial experiments. So binomial experiments have 4 properties, and that's that they all have 2 outcomes. Trials are independent, and probability for success is the same for each trial, and that there is a fixed number of trials. An example of a binomial experiment would be if you went to a garden shop and the florist assures you that a certain brand of tulips will bloom 95% of the time, and you bought 24 of these bulbs. So to find out the probability that 20% will bloom, you're going to use a binomial experiment, and you set it up by first saying 24 C20, because that's the total, and then how many combinations of 20, and then you multiply that by the probability that 20 will bloom, so they have a 0.95% probability of blooming, the florist said, so you do that to the 20th power times the percent that 4 won't bloom, so 0.05 is left when adding 0.95 to 1, and then there would be 4 left since it's 20 and 24. So you multiply that, so 24, and then math, probability, choice 3, C20 times to the 4th power. So according to that formula, the probability that exactly 20 will bloom is 2.3%. Now, if you wanted to find that the probability of more than 20 would blooming, you would set it up to find the probability of 21, 22, 23, and 24 blooming, and then you would add these all together because it's the probability that more than 20 would bloom, and those are the values more than 20. So you would use the same setup with the 24 C21 times the probability of it happening, so 21 times, multiplied by the probability of the flowers that don't bloom, so 3, and you get this answer. And now you do the same for 22, 23, and 24. So if you do the math, probability of 22 blooming would be 0.2232, and then the probability of 23 blooming would be 0.3688, and then of 24, 0.2920. So now you take all these values, all these probabilities, and you add them up. So 0.0862 plus 0.2232 plus 0.3688 plus 0.2920 equals 0.9702, and then you move this over 2 places, and the probability that more than 20 tulips bloom is 97%. So what the florist said initially matches up with this.